Okay, thank you. Thank you very much for the introduction. I'm happy to have the opportunity to present my work here. Today, I'm going to present my research on designing a novel technique to interact with public touchscreen devices. Before starting my presentation, I'd like to briefly highlight my research background. So my research specialization is in human-computer interaction, or in HCI. As you may already know that HCI is a multidisciplinary field focusing on studying, designing, and implementing novel systems that aims to improve user interaction with new technology. In HCI, we commonly explore user needs and limitations while interacting with the technology and design new techniques to facilitate the needs and help users with the overcome with these limitations. More specifically, I'm interested in designing new interaction techniques and interfaces for interactive devices, for instance, smartphones, smartwatches, or even public touch interactive devices. I'm interested in these platforms as people frequently use them to access information on the go. Now, in today's talk, I will be talking about one of my recent projects where I focus on designing novel techniques to interact with public touchscreen devices. More specifically, I will highlight my approaches that I have taken to design an alternative solutions to interact with public touchscreen devices. Now, let's start with motivating the problem. Like as you already like all know that public touch interactive devices are becoming popular in public spaces for a wide range of activities. For instance, user can purchase transport ticket in transit stations, manage their financial transactions in bank, or order food in a restaurant. And on these devices, the touch modality is considered as the primary input to interact with these devices. Now, due to the recent pandemic, there is a growing concern that public touchscreen devices become a hub for various health hazards, including infectious diseases, due to large number of people use the large number of people use them on a daily basis. Additionally, with the COVID-19 pandemic, we found that people expressed their concern on using such a public common touch interactive surface. Therefore, this warrant further investigation on an alternate input to interact with public touchscreen devices. So that's where basically we came up with a solution to interact with public touchscreen devices that does not require users to touch on the screen. Now, there were different solutions initially we thought about, like some of them require some additional instrumentation, some of them require changing the touch, like touch screens and so on. So all these things were, all those solutions involve like external like instrumentation or change to the current touch interactive devices. So this is where we were interested in not changing or not like coming up with a solution that does not require any additional instrumentation. To be more specific, we want to design something, or like for instance, an application or a solution where user can use the system without like as they can commonly use it in their day-to-day activities. For instance, like they can use it in like get support in real time with all the not need to change any sensors or any, we do not need to instrument the device. So that's where we came up with the idea of using hand palm as an alternative input space where, like as you can see, where palm facing towards the device is tracked and we place the content there. So you can imagine that the touchscreen related activities can all be performed on the palm, on the user's palm. So this is where the kind of the idea came up with the palm space. So we designed a system which we call palm space that basically leverage the palm of user's hand as an alternative input space for public touchscreen interaction. So with the palm space, user interface elements such as different buttons, different items, different lists, they are actually anchored on user's non-dominant hand, and user can use their dominant hand to interact or to select an item there. Now in HCI, we commonly go through different design process where we conduct a like set of user studies to collect users' opinion and their performance on using new technology. So we did the same here in our like when designing the Plum space. So let's have a quick look at those steps. Like we started with our like with a set of like research question. For instance, like what would be an ideal location to shift the touch input space? Like as you can see here, we can move the touch functionalities to user's palm or user's body or even in mid-air, where user can see the content on the screen. However, they can select an item by moving their hand in mid-air just above the item, so they do not need to touch the touch screen. Another example of research question is like which anchoring style we should use. As you can see here, with a relative anchoring, user element can be moved with the hand. This would allow users to adjust the input space to a comfortable position and so on. Or we can use absolute anchoring, where user elements are anchored in a fixed given location. Now, like as I mentioned, in HCI, we commonly run studies to evaluate different design choices. So we did the same here, where we recruit participants and show them all possible options. So there are other different options. For instance, what best options for selection or making item selection, what options to initiate a like initiate the window on the Plum and so on. So we showed them all the options that we like designed, and we also asked them if they have any other ideas they could suggest us. So here I'm just like briefly presenting the results based on what I discussed before. So for instance, like participant mentioned that they prefer mid-air and palm than using their body. Like they commented that they would not be very comfortable pointing on their body when they are standing in front of a public touch interactive devices and so on. And we also found that participants preferred the relative anchoring mode, where the user element moves with the user's hand and so on. Now, based on this result, we move further to explore how the Plum space can be designed to accommodate different items. So we started by looking at different factors. So here I just list some of the factors. For instance, there could be different presentation technique. There, like we could actually accommodate different number of items on Palm, or it can be placed in different locations. So let me show you what does that mean. So here, with the screen to hand presentation technique, user can see directly themselves via the camera feed, along with their user elements that are actually like anchored on their hand. So what we did, basically we placed a grid, but this grid can be replaced with a number of items, and the user can actually use their non-dominant hand to make a selection on those items. So we call this presentation technique as screen to hand technique. So like similarly, there are other presentation technique, for instance, hand to screen, where user can see an abstract hand instead of seeing themselves on the screen, because it might raise some privacy issue. So we use just the abstract hand, and the user elements are attached, as you can see, with a grid, and also a cursor can be controlled with the non-dominant hand and so on. And also we tried with different item placement. For instance, we place like 2x2 grid, 3x3 grid, 4x4 grids, and so on. And all these grid can potentially be replaced with different UI elements. And also the grid can be located on the palm or in the finger area. So we also included them in the study. So again, we conducted like user studies, and we actually asked users to perform a set of tasks. So let me show you a video that would give you an idea about like what was the study condition. So as you can see here, a user like raised their hand, and then they can actually see the grid. And there are selection tasks where we ask the participants to select different grid location. So this one is the screen to hand mode. And also we have hand to screen mode, where we did not show the participant, as I mentioned, due to privacy and other like concerns and so on. We just represent all the information with abstract hand and grid items and so on. Now, based on our results, we found that participants preferred screen to hand, where they can actually see themselves, and also they can see the grid. And also we found that if we add more items, it's actually like it takes longer time to select, as with large number of grid or with more items in the grid, we have smaller space that are allocated for each grid item that makes the selection even harder and it takes longer. And also we observed that palm is the palm area is faster than finger area. Now, based on these results, we move forward and we also conducted a another study to explore a set of design factors. And based on all these results, we finally designed our technique, which we called palm space. And then we compared the performance of palm space with mid-air technique, because with the mid-air, where the participants can just select an item by moving their finger just above the device so that they don't need to touch the screen. Now, what we did basically for evaluation for evaluate our technique or our plum space, we used we designed an application where we accommodate different elements on the plum that we commonly see in a self-service ticketing vending machine. More specifically, what we did basically, we designed a ticketing system where user can use palm and media to purchase a train ticket. So let me show you the interface for the palm. So the main user interface content options such as buy ticket, buy a card, and load a card. And then if I select an option, then it actually shows further other related information such as day pass, one-way ticket, two-way tickets, and so on. And also once I select an item, it shows further different amount option, the amount that I want to load in the card or like purchase tickets and so on. And finally, I can make the payment using debit card, credit card, and so on. So here the student is using the palm space, where actually he can just move his finger in different palm location to select different items to purchase a ticket. And here is the corresponding media version. In media version, what we did basically, we actually looked at existing interface that are commonly seen on the public ticket vending system, and we just copy or we just mimic the same interface, and we ask participants to use the media to just select tickets and so on. So again, we tracked their performance, their task completion time, error rate, and other different things, other different relevant measurements and so on. So based on our results, we found that plum space is faster than media. And also we found that user prefer plum space because it allows them to quickly access and provide haptic feedback, whereas in the media, they do not get any haptic feedback. But also participants complained about the plum space because if I use it for longer term, as I have to use both hands, it trigger more fatigue. Now, later what we did, in our previous studies, all of those were actually run in a controlled environment. So what we did basically, we sent a link to the application to participants, and participants can remotely access the link on their computer, and they can actually use the Plum to access different interfaces and perform the studies. So we were interested to see how the Plum space will be taken in actual public spaces and so on. So what he did basically, one of our colleague in France, so he was interested in evaluating it in public spaces and get people's perception on using it in different places. And he actually placed this Plum space or the system, he installed the system on his laptop and placed it in a hall and in a restaurant, and he just asked participants to interact with the system. So overall, we got very positive feedback. For instance, some of the participants commented that the system looked very good, and then also we got comment that it works really well, compared to the touchscreens and others.
2 minutes remaining.
Okay, so here is a quick discussion that I would like to highlight based on our results. We suggest that designer can consider Plum as an alternative input space for selecting item. As from our study, we see that Plum can provide faster access to items than the media. And also we suggest to consider different factors such as where to place the items, how many items can be placed, what type of layout should be used, because those factors can influence the performance of the plum space. Okay, to summarize, through this project, we showed that plum can be a viable input space and a potential substitute for touch interaction in public touch interfaces. Okay, I'd like to thank you for giving me the opportunity to present my work here. Now I'd like to open the floor for questions.